So let's start by setting up our motivating example here. The Wolf River in Tennessee, it flows past an abandoned site once used by the pesticide industry for dumping wastes, and it's going to include this insecticide aldrin. Okay, it's a highly toxic organic compound that can cause various cancers and birth defects. And typically what's done is to test whether or not these substances are present in a river is to take samples at 6/10 of a depth. But because these particular compounds are denser than water and their molecules tend to stick to particles of sediments, one might think that they could be more likely to be found in higher concentrations near the bottom of the river as opposed to just slightly under or on the surface. So what this study did was it collected the aldrin concentrations at 3 different depths in this river, and it did 10 samples at each depth. So I've put a preview of the six rows here. There's actually 30 rows in the full data set, but it should allow you to sort of see that we've got the bottom is one sort of grouping, mid-depth, okay, and then we've got the surface. And we're recording the aldrin concentration, okay? And the question is, is there a difference in the mean aldrin concentrations among or between the 3 different depths? Or maybe it's all just the same. Maybe it doesn't matter where in the river we sample. It's kind of, we anticipate the same thing. So this is our research question that we're going to sort of explore. So I always like to start with an exploratory data analysis, and this allows us to sort of just look at what the data is showing. And so I've created 3 side-by-side box plots for the 3 different depths at which we sampled: the bottom, mid-depth, and the surface. Okay, and you can sort of see, remember this middle line is your Q2 or your median, right? And you can see that this one has the highest median, the next highest median, the next highest median, as well as we get a measure sort of the spread of the data as well. And for, I also went through and calculated the sample means and the sample standard deviations just so we could have a comparison, okay? And so what you'll notice is that if we're just talking about the sample mean, of course, the sample mean for the bottom is more than the mid-depth and above the surface. That's clear, but what's not clear is whether these differences here are due to actual true differences in how this fertilizer settles in, and that, bottoms really do on average are truly always have higher concentrations than the surface, or whether maybe these differences here are just due to random chance. We just happened to gather sample sizes. We only had 10 in each sample, so maybe we just happened to get a few samples that were larger in the bottom and happened to get a few samples that were a little bit smaller in the surface. So we're going to start exploring some statistical tools for being able to explore when these differences are due to random chance and when really these are actually evidence towards there being truly different population means.